Let's go ahead and initialize DirectX. So again, whenever I make a system, one of the first things I do is make a struct where I can hold all the information relevant to that system. And then, depending on how that system relates to the rest of the application, I will go ahead and either make a global variable holding all those of that struct, or put a variable in another, typically another structure referencing that to get the correct relationship. As we have one DirectX within a video game, it's very reasonable to make this a global singleton. The first thing you need to do is make an iDirect3D, and it's done with direct3D create, and then you actually have a choice of which version to use of DirectX, and we're going to go ahead and use DirectX 9. And the reason for this is because you have the choice all the way from probably 0 or 1 or something all the way up to 10 or 11. But the problem is with 10 and 11 is that they are coupled with Windows Vista and Windows 7 respectively. So if you ever want people on Windows XP to run your game, you're going to need a DirectX 9 version of your game. And we'll just start there because it's easiest, or it's easy, and we won't worry about making multiple copies or multiple types of DirectX rendering until we get to a more advanced point. So we're going to make a DirectX pointer, or D3D pointer here, and then we're going to call direct3D create and pass in the SDK version. Again, one of these forward compatibility schemes. So something that looks like that. And then in our dispose, we're going to clean it up. And this style of Windows programming is a little bit more modern than what we were doing before, the Win32. These pointers are all what are called COM objects, and they use a reference counting scheme to keep them active. So here we created it, and here we'll release it to reduce its reference count and clean up and the associated memory and features associated with that pointer. After you create the Direct3D 9 instance, you're going to need to create a Direct3D 9 device. So pdevice, same sort of shtick. Do a release down here so I don't forget it. And then it's going to be create device. This takes a handful, so we'll look that up. Device, D3D9 create device, and it takes all these parameters. So we'll just copy those in. And I screwed it up, so this returns an H result. And then an out parameter. And then a bunch of parameters. So let's go through those parameters. Again, so here we're going to use basically as default as possible parameters to get up and running. If we were more advanced, and we'll get to this eventually, the typical way you create a device in D3D is you look at all the hardware, all the options of what the person's computer has, and choose the best one for your game. So if your game needs your best card, you'll look through and say, oh, you have an NVIDIA card that's doing this, you have an Intel graphics chipset that's doing this. Well, your $400 NVIDIA card is probably going to be the best. We'll go ahead and use that. Maybe you're on a laptop and you have a laptop video card and the Intel graphics card, or integrated chipset graphics card, and then you'd go ahead and maybe you're not making a very advanced game, so you want to use the one that's cost the lowest power per second, and so or power use, not per second, and you choose that one. So, but for now, we'll go ahead and just use whatever the default adapter is, the primary adapter for the computer. So, and then with this device type parameter, we're choosing how we want that, how we want to use that adapter and use or create a device that in what style. And there's basically a few styles. There's actually use the hardware, do absolutely nothing at all when we call DirectX, use a software written version that that Microsoft's written basically, and use our own software written version, and we will use the hardware itself. And the only reason you'd not want to use these is maybe for if you wanted to run a client without graphics, you might use this one. If you wanted to test out bugs in the hardware or the driver associated with the hardware, you might use the reference one. And if you were motivated, you could use the write your own software rasterizer for some reason. Next is the focus window, so we'll need the window passed in. Next is a set of D3D create flags. Again, these are a bunch of flags that allow you to customize and let D3D know what type of application you're making. The only one that you actually need to set to get things going is what type of vertex processing you want to use. And the choices are hardware, mixed, or software. And we're going to go ahead and choose hardware because most modern cards these days support hardware. And then the next parameter is a set of more flags or more parameters in a different struct. And this has that same struct passing style we saw earlier. And go ahead and look at its parameters. I'll pass it in. Check its parameters out. And again, most of these parameters are very reasonable as defaults. The only two we actually need to set up are the windowed parameter. We're going to set that to true, so we run in a window because it's a lot easier for debugging. And then the swap effect parameter. And for swap effect, whoops. Swap effect, our choices are a handful. Then these basically, when you're making a graphics application, 3D application, there's a decision of how to get what you're drawing onto the screen. You can't actually draw right onto the screen. It doesn't work that way. Like your screen is in a different buffer than the area you draw to. And there's a set of what you might have heard of a double buffering or triple buffering of techniques that advance the buffer you're drawing from a place where you can draw to it to a place where it can be rendered on the screen. And this swap effect specifies how that advancement takes place. One you might be familiar with is flip, is where you have multiple buffers and you just switch which buffer is being drawn at the current time. This discard effect is probably the most featureful with the most cost. It says you will draw the whole screen every time, and then D3D can throw it away when you're done with it and recycle it in whatever way it wants. Maybe it'll give it to you again next frame. Maybe it'll use it for something completely different and give you a different area of memory the next time. So discard is the most useful if you can guarantee that you're drawing the whole screen every frame. And in most video games, you draw the whole screen every frame. So we're just going to go ahead and specify that. You'll notice we're getting a bunch of squigglies because we haven't properly included the right header files to make this all work. And again, we'll go to the create function, look at the bottom, and see that we need the include of the D39 header file to make this go. And the other thing we're going to need is the D3D9 lib. And there's a couple ways to include libraries in your file, in your project. First, you could right-click in here, and there's a section under Properties, Linker, Input. There's a bunch already here. You could add to this list here. This lets you customize per configuration and platform, which honestly I'm not sure is super useful, because you pretty much always want the libraries included. Yeah, maybe there's a debug version of the library versus non-debug version, but for the most part, you want them always. Whenever you include this file and build it, you're going to want this library, no matter what project it gets put into. It's kind of hassle to include project or mucks with the linker settings just to get your program to compile. So there's this special pragma that I just learned about a little bit ago that allows you to include libraries. So let's search for that, pragma include library. See if that gets us what we're looking for. Yeah, here's a web page which specifies how to include a library just through a pragma file. So it's pragma comment, and then it's lib, and then the name of the lib. And yeah, I've never really used this before, but it seems like it's probably a pretty useful way to include library files in your project. So, whoops, I put a ampersand here, and looking around. Yeah, okay, looks pretty good. Let's compile and run. Got an error. Oh, we put this a little bit too low compared to where we're actually using the information. And then DirectX init now takes the handle to the window that we just made, so main wind. There we go. We should have, in theory, created. Let's walk through this to make sure we did something actually useful. We step over. We've created DirectX. We have a valid pointer. We set up our D3D present parameters, and they look reasonable. We step through. We get an OK result. We've created a device, and then not doing anything with it, but then we shut down the game and we destroy these pointers, and we're good. All right, so in the next video, we'll go ahead and draw something to the screen.